Hello friends, welcome to Automation Community. Today in this video we are going to discuss an example in which we will use push buttons. So let's look at the example first. Example 25. When push button is pressed and released, then machine 1 will be on. And then again, when same push button is pressed and released, then machine 1 will be off and machine 2 will be on. And then when same push button is pressed and released, then machine 2 will be off and machine 3 will be on. So for this example, we are using a single push button. Firstly, to turn on machine 1, and in the second press and release, machine 1 will be off and machine 2 will be on, and then in a third press and release, machine 2 will be off and machine 3 will be on. So in this example, we will be using some normally open contacts as well as normally closed contacts. We will also be using some memory bits, and we will also be implementing some logic gates like and, or. So let's let's move to EcoStruxure Machine Expert, where we will draw a ladder diagram for this example. I will open EcoStruxure Machine Expert Basic. I will keep read protection as inactive and write protection as inactive. We can also keep it active, then there will be password required. So in this case, when these are inactive, then uploading the application from the controller is unrestricted, and downloading an application to the controller or modifying the application in the controller is unrestricted. So when we keep it active, then uploading the application from the controller will be restricted, and downloading an application to the controller or modifying the application in the controller will be restricted. That is, we have to give a password for uploading and download. So we will keep these inactive and then click on apply. Then I will click on configuration tab. So here we have to configure a device. That is, we have to select a logic controller from this list. Here is a list of different logic controllers with different configuration. So I will select TM221C24R. I will click on it and drag it to here. Do you want to replace? You may lose some features and associated configurations. I will click on yes. So here is a device description about the device we have selected, that is TM221C24R. It has 14 digital inputs, 10 relay outputs, 2 analog inputs, 1 serial line port, and 100 to 240 volt AC power supply controller with removable terminal blocks. Then after that, I can also go to serial line, where I will update protocol and serial line settings. So I will click on protocol and I will select it as TMS2GDB. When I select protocol as TMS2GDB, then there is no need to update the serial line settings. After that, I will click on apply. Then I will go to programming tab. So here we will be drawing ladder diagram for single push button to turn on and turn off 3 outputs. So I can also click on this option for a full screen mode, and then I can also zoom into it like this. So firstly, I will insert normally open contact, and I will assign address to it as I0.0. I will also add a coil here, and I will assign address to it as Q0.0. I will also add symbol to it as machine 1. Yes. And then I will latch it here. So I will assign address to this normally open contact as Q0.0. And then I will connect it like this. Then I will add a new rung here in which I will insert a normally closed contact first. I will assign address to it as I0.0. I0.0. I will also add symbol to it as switch. Yes. And then I will insert a normally open contact here. I will assign address to it as Q0.0, which is machine 1. And then I will insert a coil. I will assign address to it as M0, which is a memory bit. And then I will latch it here, so I will insert one more normally open contact here. And I will assign address to it as M0. And then I will click on this option and draw a line like this. And then I will add a new rung here. So firstly, I will insert a normally open contact. I will assign address to it as I0.0. I will also add one more normally open contacts, actually two normally open contacts, and then a coil. And I will assign address to this normally open contact as M0. I will also add symbol address to this coil as M1. So I will latch M1 here. So I will assign address to it as M1. I will connect it like this. Then I will add a new rung and I will use this M1 to turn off machine 1. So I will insert normally closed contact here and I will assign address to it as M1. So when switch is turned on and turned off, machine 1 will be on, and then when it is again turned on and turned off, then M1 will be activated, and when M1 will be activated, machine 1 will be off. And also when M1 will be activated, that is when machine 1 will be off, then machine 2 will be on. So I will insert a normally open contact here and I will assign address to it as M1. And then I will insert a coil here. I will assign address to it as Q0.1. I will also add symbol to it as machine 2. Yes. Then I will add a new rung in which I will insert a normally closed contact. And I will assign address to it as I0.0, which is a switch. And then I will insert one more normally open contact here. And I will assign address to it as Q0.1, which is machine 2. And then I will insert a coil here for memory bit, that is M2. And I will latch M2 here, so I will insert a normally open contact here. And I will assign address to it as M2. And then I will connect it like this. Then I will add a new rung here in which I will insert a normally open contacts. I will assign address to this normally open contact as I 0.0, which is the switch, and M2, which is a memory bit. And then I will insert a coil here, which will be used for another memory bit, that is M3. And I will latch this memory bit here, so I will insert one more normally open contact and insert it here. So I will assign address to it as M3. And then I will connect it like this. So I will use this memory bit M3 to turn off machine 2. So here I will insert normally closed contact here, and I will assign address to it as M3. Then I will add a new rung in which I will use this M3 to turn on machine 3. So I will insert a normally open contact and I will assign address to it as M3. And then I will insert a coil here for machine 3. I will assign address to it as Q0.2. I will also add symbol to it as machine 3. Yes. So in the first time, when switch is turned on and turned off, the current will flow through it and machine 1 will be on. As we have latched machine 1 here, so when switch is turned off after turning it on, machine 1 will remain on. And then when switch is turned off and machine is turned on. So in the previous rung, we have seen when switch is turned on and then turned off, machine will be on. So when switch is off, after turning it on and then off, the current will flow through it, and machine 1 is on, the current will flow through it, and M0 will be true. And we have latched it here. Then when again switch is turned on and M0 is on, then again the current will flow through it and M1 will be activated. So M1 will be activated in the second press and release. Actually, M0 gets activated on a second press, and we use this M0 for M1, and then we use M1 to turn off the machine 1. So for M1 to turn off machine 1, we use another memory bit, that is M0. So here when switch is turned off and machine 1 is on, M0 gets activated. It stores the data that once switch was turned on and turned off. That is, there has happened a press and release to switch. So M0 gets activated. This memory bit stores that switch is already pressed and released for the first time. And this data will be used for a second press. So what should it do on a second press? So M0 stores data. And when M0 stores data, that switch is already pressed and released and machine is turned on, then when again switch is pressed and released, and also it has stored that switch was once turned on and turned off and machine 1 got on, then the current will flow through it and M1 gets activated. So M1 gets activated when M0 stores data that the switch was already pressed and released and machine 1 was on. So it confirms that there is going to be second press and release. And then when M1 gets true, that is when switch is second time pressed and released. So on a second press and release, M1 gets activated, and when M1 gets activated, machine 1 turns off. And then when M1 gets activated, the current will flow through it and machine 2 will be on. And then when switch is turned off and machine 2 is on, then M2 will be on. And this M2, that is a memory bit, stores that in the past, switch was pressed and released 2 times. So that is, it stores that in the first press and release, machine 1 was on, and the second press and release, machine 1 was off, and also machine 2 is on. So it stores that there is going to third press and release. So M2 stores that. So M2 gets activated when the second press has happened. So when again in the third press and release, the switch will be on and M2 is already on. That is, M2 has already stored data that switch was 2 times turned on and turned off. And then M3 gets on. And when M3 gets on, here machine 2 gets off. So in a third press and release, machine 2 gets off. And also when M3 gets on, machine 3 gets on. So I will exit full screen mode and then I will compile the program. And then I will go to commissioning and launch simulator. And then I will start controller. To do so, click OK. So I will go to programming and click on full screen mode. So when I turn on switch and then turn off, the current will flow through it and machine 1 gets on. And with that, when switch is off and machine 1 is on, M0 stores that data. That is, switch is already pressed and released 1 time. And then we use this data that is stored in M0, and then when we press and release the push button or switch, that is when we turn it on and turn off second time, then M1 gets activated. That M1 stores data that switch is second time turned on and turned off. And this data is used, which is stored by M1, is used to turn on machine 2. And also it is used to turn off machine 1. And then this M1 stores data that switch is pressed and released 2 times. And then when switch is false and machine 2 is on, and then M2 gets true. So here this M2, this memory bit stores data that switch is off and machine 2 is on. That is, switch is pressed and released 2 times. And then when switch was pressed and released 2 times, when pressed and released third time, the current will flow through it and M3 gets true. And we will use this M3 which gets true on a third press to turn off machine 2. And we will also use this M3 that stores data that switch is turned on and turned off third time to turn on machine 3. It was all about this example. Thank you for watching.